Question number 1, part A. For Roman 1, we are supposed to round off 9.67 to ones. Okay, so this is an approximation problem. So this one to be rounded is just going to be 10 because 6 here is greater than 5. So the answer is going to be 10. For Roman 2, we are supposed to round off 0.205 to 1 decimal place. Okay, so for this one, since this 0 is less than 5, then the value is going to be 0.2. And this is going to be our answer. For Roman 3, we are supposed to round off 0.0197 to 2 decimal places, and then we are supposed to estimate the value of that expression. Okay, so since this 9 here is greater than 5, then the estimated value for this one is going to be 0.02. Okay, so for now, to estimate the value of this expression, we are going to replace these values with the rounded figures. Then our expression is going to be 10 times 0.2 over 0.02, of which this becomes 2 over 0.02. Okay, so now let us multiply by 100 both in numerator and denominator. Then we are going to have 200 over 2. Solving this, we are getting 100. And this is going to be the estimated value. For part B, simplify the expressions. So for Roman 1, we've been given the expression there. Okay, so for this one, we have to see that this is the radical problem. Okay, so first, let us expand this expression. Then we are having 3 times 4 minus 3 times 2 under root 3 plus under root 2 times 4 minus under root 2 times 2 under root 2. So next, let us multiply them. Then we are having 12 minus 6 under root 2 plus 4 under root 2 minus 4. Okay, so now let us combine the like terms. Then we are having 12 minus 4 plus, in brackets, 4 minus 6 under root 2. Solving further, we are having 8 minus 2 under root 2. And this is going to be our final answer. For Roman 2, we have under root 40 times under root 45. Okay, so first, let us express these numbers in terms of their prime factors. Then we are going to have under root 2 times 2 times 2 times 5 times under root 3 times 3 times 5. Okay, so next, let us now separate those numbers which can make squares. Then we are going to have under root, in brackets, 2 times 2 times 2 times 5 times under root, in brackets, 3 times 3 times 5. Okay, so we know that the root of 2 times 2 equals to 2, and the root of 3 times 3 is 3. Then let us replace those values. Our expression is going to be 2 under root 2 times 5 times 3 under root 5. Okay, so now let us combine the roots. Then we are having 2 times 3 times under root 2 times 5 times 5. And also the root for 5 times 5 equals to 5. Then our expression is going to be 6 times 5 times under root 2. Solving this, we are having 30 under root 2. And this is going to be our final answer. For part C, express 0.3636 and so on in form of A over B, where A and B are integers and B is not equal to 0. Okay, so this is the repeating decimal problem. We know that repeating decimals are the one that goes on and on and on. Meaning we can write 0.3636 as 0.36 with dots, meaning 3 and 6 repeats without ending. Okay, so first we are going to let x equals to 0.36 and these 36 are repeating, and we are going to call this as equation number 1. Okay, so now let us multiply by 100 both sides. Since we have two numbers that are repeating, then our equation is going to be 100x equals to 36.36. And then we are going to call this as equation number 2. Okay, so now let us take equation number 2 and then we are going to minus with equation number 1. Then our expression is going to be 100x minus x equals to 36.36 minus 0.36, of which this becomes 99x equals to 36. Okay, so now let us divide by 99 both sides. Then our equation is going to be x equals to 36 over 99. Simplifying this, we are having x equals to 4 over 11. And this is going to be our answer. Question number 2, part A. Simplify. For Roman 1, we have been given that expression. Okay, so this is an exponential problem. So first, let us express each term as a base 3. Then our expression is going to be 3 power 3 over 4 times 3 power 1 over 4 times 3 power negative 2 over 2. Okay, so now since the bases are the same, we are going to add the exponents. Then our expression is going to be 3 power, in brackets, 3 over 4 plus 1 over 4 minus 2 over 2. Okay, so after adding the values, we are having 3 power 0, of which, solving this, the answer is going to be 1. And this is going to be our final answer. For Roman 2, we are supposed to simplify log 10 base 3 plus log 8.1 base 3. So this is the logarithm problem. So first, let us apply the product rule of logarithm for our given expression. Then our expression is going to be log base 3 10 times 8.1, which, solving this, it becomes log 81 base 3. Okay, so next, let us express 81 in exponential form to base 3. Then our expression is going to be log 3 power 4 base 3. Okay, so now let us apply the exponential rule. Then our equation is going to be 4 log 3 base 3. But we know that log 3 base 3 equals to 1. Then our expression is going to be 4 times 1, which equals to 4. And this is going to be our final answer. For part B, if n log 125 base 5 equals to log 64 base 2, find the value of n. Okay, so let us first express the numbers in exponential form for both sides. Then our equation is going to be n log 5 power 3 base 5 equals to log 2 power 6 base 2. Okay, so next we are going to apply the exponential rule of logarithm. Then our equation is going to be 3n log 5 base 5 equals to 6 log 2 base 2. Okay, so we know that log 5 base 5 equals to 1 and log 2 base 2 equals to 1. Okay, so let us now substitute the values. Our equation is going to be 3n equals to 6. Okay, so next let us divide by 3 both sides. Then we are going to have n equals to 2. And this is going to be our answer. Question number 3, part A. Factorize the following expression. For Roman 1, we have 16y squared plus xy minus 15x squared. Okay, so this is the algebraic problem. Okay, so for this one, first we are going to take the product of the coefficients of y squared and x squared, which are this one, 16 and negative 15. And then we are going to look for the two factors from this product that can be added to give the coefficient of x, y at this position, which is just 1. Okay, so those two factors are 16 and negative 15. Then we are going to split the middle term by replacing these two factors. Then our expression is going to be 16y squared plus 16xy minus 15xy minus 15x squared. Okay, so next let us separate the terms. Then our expression is going to be in brackets 16y squared plus 16xy minus 15xy plus 15x squared. Okay, so next let us fact out the common terms from each expression. Then we are having 16y in brackets y plus x minus 15x in brackets y plus x. Okay, so next we are going to fact out this one, y plus x, from the whole expression. Then we are having in brackets y plus x in brackets 16y minus 15x. And this is going to be our final expression. For Roman 2, our expression is 4 minus in brackets 3x minus 1 squared. Okay, so for this one, first we are going to express 4 as in exponential form. Then we are having 2 squared minus in brackets 3x minus 1 squared. Okay, so for this one, we can see that this is the difference of 2 squared, and it can be factorized as in brackets 2 plus 3x minus 1 times in brackets 2 minus in brackets 3x minus 1. Okay, so next, let us combine the terms inside the brackets. We are having, in brackets, 1 plus 3x, in brackets, 3 minus 3x. So next, we are going to factor out 3 from here. Then our expression is going to be 3 in brackets 1 plus 3x in brackets 1 minus x. And this is going to be our final expression. Part B of the question, at Moiva's graduation ceremony, 45 people drank Pepsi Cola. 80 drank Coca-Cola and 35 drank both Pepsi Cola and Coca-Cola. By using a Venn diagram, we are supposed to find out how many people were at the ceremony if each person drank Pepsi Cola or Coca-Cola. Okay, so this is the set problem. We have been given people who drank both drinks are 35. People who drank Pepsi Cola only are going to be 45 minus 35, which after solving this equals to 10. And for people who drink Coca-Cola only are going to be 80 minus 35, which after solving this, we are having 45. Okay, so now let us represent this information in our Venn diagram. So we are going to sketch our table, and then we are going to have 2 cycles inside our table. And then this one is for Pepsi Cola, and this is for Coca-Cola. Okay, so the value here is going to be 10, here is 35, and here is 45. Okay, so to get the total number of people, we are just going to take 10 plus 35 plus 45, of which after solving the values, we are having 90. And this is the total number of people were around. Question number 4, part A. Given the 3 vectors A with those values, B with those values, and C with those values, we are supposed to determine the magnitude of their resultant. Okay, so this is the vector problem. To find the magnitude of the resultant, we are going first to find the resultant vector by summing up the 3 vectors. So we are saying resultant equals to A plus B plus C. Okay, so let us take values from our question. Then we are having resultant equals to 4i plus 6j plus 4i plus 10j plus 2i and plus 4j, of which after summing the values, we are having 10i plus 20j. Okay, so to find the magnitude of R, we are going to take under root 10 squared plus 20 squared. Okay, so let us solve this. We are having under root 500. Okay, so next let us simplify further this one. We are having under root 5 times 10 times 10. We can also write this as 10 under root 50. And this is going to be the magnitude required. For part B, Camila walks 5 kilometers northeast, then 3 kilometers due east, and afterwards 2 kilometers due south. we are supposed to represent this displacement together with the resultant displacement graphically using the scale of 1 unit equals to 1 kilometer. Okay, so again, this is the vector problem. Okay, so we've been told that we are supposed to consider 1 centimeter in a paper representing 1 kilometer in a ground. Okay, so let us sketch our problem. So our starting point is going to be here, and here is going to be O. And then we are going to draw our line representing the northeast direction. And then we are having another line here going east, and another line here going south. And then we are going to draw another line here representing our resultant. Okay, so here we are having A, here is B, and here is C. And here we have 5 kilometers, here is 3 kilometers, and here is 2 kilometers. So next step is just to measure the length of this line. So line OC after measuring equals to 4.1 centimeters. Okay, so since we've been told that 1 centimeter represents 1 kilometer, then the length of the determinant is 4.1 kilometers. Part C, show that triangle ABC is a right-angled triangle where A equals to those coordinates, B equals to those coordinates, and C equals to those coordinates. Okay, so this is the geometric problem. We have to remember that right-angled triangle obeys Pythagoras theorem. Okay, so first we are going to sketch our problem. Then we are going to find the distances between points, and then later we are going to apply the distances into the theorem to see if it obeys the Pythagoras theorem. So let us sketch our triangle. So here is point A with -2, -1. Here is point B with 2, 1. And here is point C with 1, 3. Okay, so now let us recall the distance formula, which says distance equals to under root in brackets x2 minus x1 squared plus y2 minus y1 squared. Okay, so first we are going to take point A and point B, and then we are going to call this as distance 1. Then our distance 1 equals to under root in brackets -2 minus 2 squared plus in brackets -1 minus 1 squared, of which after solving the values we are going to have under root 20. Okay, so next we are going to take point A and C, and then we are going to call this as distance 2. So distance 2 equals to under root in brackets -2 minus 1 squared plus in brackets -1 minus 3 squared, of which after solving the values we are having under root 25. So next we are going to take point B and C, and then we are going to call this as distance 3. So D3 equals to under root in brackets 2 minus 1 squared plus in brackets 1 minus 3 squared, of which after solving the values we are having under root 5. Okay, so now let us recall the Pythagoras theorem, which says c squared equals to a squared plus b squared. So we are going to substitute d1 as a, d2 as c, and d3 as b. So we are saying d2 squared equals to d1 squared plus d3 squared. Okay, so substituting the values we are going to have under root 25 squared equals to under root 20 squared plus under root 5 squared, of which this becomes 25 equals to 20 plus 5. Solving from our right hand side, we are having 25 equals to 25. Now we can see that our right hand side and our left hand side are equal. Then this is the right angled triangle. Question number 5, part A. In the figure below, AB equals to 10 centimeters, AX equals to 6 centimeters, CX equals to 8 centimeters, and AB is parallel to DC. For Roman 1, we are supposed to show whether triangles AXB and CXD are similar or not. Okay, so for this one, we are going to use different theorems to show whether triangle AXB and CXD are similar or not. Okay, so from the figure, we can say that angle XAB equals to angle XCD because they are alternate interior angles since line AB and line DC are parallel. And also, we can say that angle XBA equals to angle XDC because they are alternate interior angles since line AB and DC are parallel. And also, we can say that angle AXB equals to angle DXC because vertically opposite angles are equal. Okay, so since all three corresponding angles are equal, then triangles are similar by theorem AAA, meaning all three corresponding angles are equal. For Roman 2, we are supposed to find the length CD. Okay, so since triangles AXB and CXD are similar, then the corresponding sides are proportional, meaning they have a constant ratio. Then we can write this mathematically as AX over CX must equal to XB over XD, which also equals to AB over CD. Okay, so let us consider this ratio AX over CX equals to AB over CD. Let us now substitute the values from the figure given. Then we are having 6 over 8 equals to 10 over CD. Okay, so next, let us apply the cross multiplication for this one. We are having 6 CD equals to 8 times 10. So let us now divide by 6 both sides. Then our equation is going to be CD equals to 8 times 10 over 6, of which after solving the values, we are going to have CD equals to 13.33 centimeters. For Roman 3, we are supposed to find the ratio of the areas of a triangle AXB and CXD. Okay, so for this one, the ratio of area of similar triangles can be simply obtained by squaring the constant ratio of the sides. We can write this as ratio of the area equals to AX over CX squared. Okay, so now substituting the values we are having 6 over 8 squared, of which after simplifying this, we are going to have 9 over 16. We can also write this one in a ratio format as 9 ratio 16. For part B, using a ruler and a compass, construct an angle of 90 degrees. Okay, so this is the geometry problem, and let us construct the problem. We are going to start by drawing the horizontal line with the center O. Next, we fixed our divider and mark point M and N. Then, we fixed our divider at point M and N, and we are going to draw the curve lines that intersect at Q. Using ruler, connect point O and Q. Then, angle QOM is right angle. We can also verify the result by measuring angle QOM by using a protractor. Question number 6, part A. In the preparation of a Fanta orange drink, a bottling filling machine can fill 1,500 bottles in 45 minutes. How many bottles will it fill in 4.5 hours? Okay, so this is the variation problem. From the problem, we can say that number of bottles is directly proportional to time taken. Okay, so next, let us introduce K as a constant of proportionality. Then our equation is going to be N equals to KT. So let us now make K as a subject. Then we are having K equals to N over T. Okay, so to find the value of a constant here, we are going to substitute N with 1,500 and T with 45 minutes. Then our equation is going to be K equals to 1,500 over 45. Simplifying this, we are having 100 over 3. Okay, so now we have the values for our constant K. Then we can find the number of bottles when time is 4.5 hours, which equals to 270 minutes. Then using the same formula for K and replacing the values of K, then our equation is going to be 100 over 3 equals to N over 270. Then let us cross multiply our equation. Then we are going to have 3N equals to 100 times 270. Now let us divide by 3 both sides. Then we are having N equals to 100 times 270 over 3. Simplifying this further, we are going to have N equals to 9,000. Therefore, these are number of the bottles required. Part B of the question, if X varies directly as Y and inversely as W, find the values of A and B in the table below. So we've been given the table with several values there. Okay, so for this one, this is the variation problem. We've been told that X varies directly as Y and X varies inversely as W. Okay, so now let us introduce the proportionality constant K. then our equation is going to be x equals to k y over w. Let us now make k as a subject, then our equation is going to be k equals to wx over y. Okay, so we have x equals to 8, y equals to 4, and w equals to 2. From the above table given, let us now substitute these values in order to find the value of k. Then our equation is going to be k equals to 2 times 8 over 4. After solving this, we are having 4. Okay, so now to find the value of a, we are going to substitute x equals to 6, y equals to a, w equals to 3 from the table, and then we have k equals to 4. Then our equation is going to be 4 equals to 3 times 6 over a. Let us now make a as a subject, then we are having a equals to 3 times 6 over 4. Solving this, we are having a equals to 4.5. And also, to find the value of b, we are going to substitute x equals to b, y equals to 2, and w equals to 4 from the table, and then we have k equals to 4. Then our equation is going to be 4 equals to 4 times b over 2. Now let us make b as a subject, then our equation is going to be b equals to 4 times 2 over 4. Solving this, we are having b equals to 2. And those are the values of a and b required. Question number 7. A computer is advertised in a shop as having a list price of Tanzania shillings 2.5 million plus value added tax of 20%. The sales manager offers a discount of 25% before adding the VAT. For part A, we are supposed to calculate the list price including VAT. Okay, so this is the percentage problem. The list price including VAT equals to 2,500,000 plus 20% of 2.5 million as VAT, which equals to 2.5 million plus 20 over 100 times 2.5 million, of which after solving the values we are having 3 million, and this is the value required. For part B, we are supposed to calculate the amount of a discount before VAT is added. Okay, so the amount of a discount before VAT is added is equal to 25% of 2.5 million. So we are going to take 25 over 100 times 2.5 million, of which after solving the values we are having 625,000, and this is going to be the value required. For part C, we are supposed to calculate the reduced final price of the computer. Okay, so for this one, we are going to take 2.5 million minus 25% of 2.5 million as a discount plus 20% of 2.5 million as VAT. So let us take the values. So here we are going to have 2.5 million minus 25 over 100 times 2.5 million plus 20 over 100 times 2.5 million, of which after solving the values we are having 2,375,000, and this is going to be our answer. Question number 8, part A. If the sum of the nth term of a geometric progression within first term 1 and common ratio 1.5 is 31/16, find the number of terms. Okay, so this one is the geometric progression problem. We've been given that the first term G1 equals to 1. The common ratio R equals to 1/2. And here we are supposed to find the number of terms, which is denoted as n. Okay, so now let us recall the formula to find the sum of the terms in the geometric progression, which says Sn equals to G1 in brackets R power n minus 1 over R minus 1. Okay, so now let us substitute the given values. Then we are having 31/16 equals to 1 in brackets 1/2 power n minus 1 over 1/2 minus 1. Let us now simplify the denominator for our right hand side. Then our equation is going to be 31/16 equals to 1 in brackets 1/2 power n minus 1 over negative 1/2. Let us now simplify our right hand side. Then our equation is going to be 31/16 equals to 2 in brackets negative 1/2 power n plus 1. Okay, so next let us divide by 2 both sides. Then our equation is going to be 31/32 equals to negative 1/2 power n plus 1. Okay, so next we are going to combine the constant terms. Then we are going to have 1/2 power n equals to 1 minus 31/32. Solving this, we are having 1/2 power n equals to 1/32. Okay, so next let us express our right hand side as exponent of base 1/2. Our equation is going to be 1/2 power n equals to 1/2 power 5. Okay, so now let us compare the components since their bases are the same. Then our equation is going to be n equals to 5. And this is going to be the number of terms. Part B, how many integers are there between 14 and 1000 which are divisible by 17? Okay, so this is the arithmetic progression problem for integers between 14 and 1000. The number that can be divided by 17 start at 17. This implies that the first term, which is a1, is 17 and the common difference d is 17. Therefore, our integers will be 17, 34, 51 and so on up to 986. By making analysis of the trend, the number of terms n equals to 58. Question number 9. In the figure below, AE equals to 20 meters, EB equals to 20 under root 2 m, and DAE equals to 45 degrees. For part A, we are supposed to find the length DE, AD, and AB. Okay, so starting with the length dE, we are going to use the sine formula which says sine theta equals to opposite side, in our case is dE, over hypotenuse side, in our case is AE. Okay, so we've been given theta equals to angle DAE, which equals to 45 degrees, and AE equals to 20 meters. Then let us substitute the values into our formula. Then our equation is going to be sine 45 degrees equals to dE over 20. Okay, so now let us make dE as a subject. Then our equation is going to be dE equals to 20 times sine 45 degrees. Okay, so reading from the table, the value of sine 45 degrees equals to 0.701. Okay, so let us substitute these values into our equation. We are having dE equals to 20 times 0.7071. Solving this, we are going to have dE equals to 14.14 meters. Okay, so next we are going to check the length AD using the cosine formula, still saying cos theta equals to adjacent side, in our case is AD, over hypotenuse side, in our case is AE. Okay, so we've been given theta equals to angle DAE, which equals to 45 degrees. AE equals to 20 meters. Okay, so now let us substitute the values into our formula. Our equation is going to be cos 45 degrees equals to AD over 20. Okay, so now let us make AD as a subject. Then our equation is going to be AD equals to 20 times cos 45 degrees. Okay, so the value of cos 45 degrees from the table equals to 0.7071. Okay, so now substituting this, we are having AD equals to 20 times 0.7071. Solving this, we are having AD equals to 14.14 meters. Our next line is length AB. So consider triangle ADB. Let us apply the Pythagoras theorem, which says AB squared equals to AD squared plus DB squared. But DB equals to DE plus EB, which also equals to 14.14 plus 20 under root 2. The value of under root 2 equals to 1.414 from the table. Okay, so now substituting this, we are having dB equals to 14.14 plus 2 times 1.414. Solving this, we are having dB equals to 42.42. Then our theorem will be AB squared equals to 14.14 squared plus 42.42 squared. Solving this, we are having AB squared equals to 1999.4. Let us now apply the square root. We are having AB equals to under root 1999.4. Reading this from the table, we are having AB equals to 44.71 meters. And those are the answers required. For part B, we are supposed to find the area of a triangle ABE, leaving the answer in a third form. Okay, so for this one, area of a triangle ABE equals to area of a triangle ADB minus area of a triangle ADE. So using area of a triangle formula, we are going to have 1 over 2 times AD times DB minus 1 over 2 times AD times DE. Okay, so now let us substitute the values we have. Our equation is going to be 1 over 2 times 14.14 times 42.42 minus 1 over 2 times 14.14 times 14.14. After solving the values, we are having 199.94, which is approximated to be 200. Therefore, the area is going to be 2 times 10 squared meter squared. And this is represented in a third form as requested. Question number 10, part A. Solve the equation 4x squared minus 32x plus 12 equals to 0 by using the quadratic formula. Okay, so this is the quadratic problem. Let us recall the quadratic formula, which says x equals to negative b plus or minus under root b squared minus 4ac over 2a. Okay, now from our equation, a is 4, b equals to negative 32, and c equals to 12. Let us now substitute these values into our equation. We are going to have x equals to negative 32 plus or minus under root negative 32 squared minus 4 times 4 times 12 over 2 times 4. Solving this, we are having x equals to 32 plus or minus under root 832 over 8. Simplifying this, we are having x equals to 32 plus or minus 8 under root 13 over 8. We can simplify this as x equals to 4 plus or minus under root 13. Therefore, x equals to 4 plus under root 13, or x equals to 4 minus under root 13. And those are going to be our answers. Part B of the question, Anna is 6 years younger than her brother Jerry. If the product of their age is 135, find how old is Anna and Jerry. Okay, so this one is the algebraic problem. Let us assume x equals to Jerry's age. Then Anna's age will be x minus 6. The product of their age is 135. Then we can write this as x times x minus 6 equals to 135. Okay, so now let us expand our left-hand side. Our equation is going to be x squared minus 6x equals to 135. Let us now write this equation in a standard quadratic format. Our equation is going to be x squared minus 6x minus 135 equals to 0. Okay, so now we are going to apply the quadratic formula in order to solve for x. The formula says x equals to negative b plus or minus under root b squared minus 4ac over 2a. Now from our equation, a equals to 1, b is negative 6, and c is negative 135. Okay, so now let us substitute these values into our formula. Then our equation is going to be x equals to negative 6 plus or minus under root negative 6 squared minus 4 times 1 times negative 135 over 2 times 1. Solving this, we are having x equals to 6 plus or minus 24 over 2, which can be further simplified as x equals to 3 plus or minus 12. Then x equals to 3 plus 12, which solving this we are having 15, or x equals to 3 minus 15, which solving this we are getting negative 12. So for this one we are going to take the positive value, which equals to x equals to 15, because the age cannot be negative. Therefore Jerry's age equals to 15 years. To get the value of Anna's age, we are taking 15 minus 6, which solving this we are having 9 years. And those are their ages. Question number 11. Zelda wanted to buy oranges and mangoes for her children. The oranges are sold at Tanzania shillings 150 each, and the mangoes are sold at shillings 200 each. She must buy at least 2 of each kind of a fruit, but her shopping bag cannot hold more than 10 fruits. If the owner of the shop makes a profit of shillings 40 on each orange and shillings 60 on each mango, we are supposed to determine how many fruits of each kind Zelda must buy for the shop owner to realize maximum profit. Okay, so this is the linear programming problem. Okay, so first we are going to let x be the number of oranges bought and y be the number of mangoes bought. Okay, so next let us form the inequalities. We are going first to introduce the non-negative inequalities since the number of fruits cannot be 0. So we are saying x should be greater or equal to 0 and y should be greater or equal to 0. We have been told that Zelda bought at least 2 of each type of fruits, meaning x and y are both greater or equal to 2. Then our inequality is going to be x is greater or equal to 2 and y is greater or equal to 2. And also we've been told that shopping bag cannot hold more than 10 fruits, meaning the sum of x and y must be less or equal to 10. Then our inequality is x plus y is less or equal to 10. Okay, so next let us form the boundary lines. From the inequalities we have, our first boundary line is going to be x equals to 2. The second one is y equals to 2. And the last one is x plus y equals to 10. Okay, so now let us form the objective function. Since the aim is to realize the maximum profit, our objective function is going to be function of x, y max equals to 40x plus 60y, representing the profit to be made by each type of a fruit. And our objective is to find the possible values of x and y that is going to give maximum value of the objective function. Okay, so next we are going to draw the graph in order to find the feasible region for our solution. Okay, so first we are going to start by shading region for non-negative inequalities. X is greater or equal to 0 and y is greater or equal to 0. Our next line is going to be x plus y equals to 10. We are going to use the intercept method to find the 2 points on the line. Then we are saying when x equals to 0, for this one y is going to be 10 and our point is going to be 0, 10. And then when y equals to 0, x is going to be 10. Then our point is going to be 10, 0. Okay, so next we are going to draw the lines and we are going to shade the region according to their boundary lines. Then next we are going to draw the line x equals to 2 and y equals to 2, and then we are going to shade according to their inequalities. After that, our final graph is going to be like this. Okay, so from the graph, we have the feasible region and the corner points that is going to give us the possible solutions. So let us summarize the corner points in a table, and then we are going to apply the values into our objective function. Okay, so we are going to draw the table. So here we have corner points, and here we have the objective function, which is function of x, y max equals to 40x plus 60y. Okay, so from our graph, our first point is point A with 2, 2, and applying these values into our objective function, the answer here is going to be 200. Our next point is point B with 8, 2, of which the objective function value is going to be 440. The next point is point C with 2, 8, and the value here is going to be 560. Okay, so now from the table, we can see that point C gives maximum value of the function. Therefore, Zelda must buy 2 oranges and 8 mangoes for the shop owner to realize the maximum profit. Question number 12. The heights of 50 plants recorded by a certain researcher are given below. So we've been given several information there. For part A, we are supposed to copy and complete this tally table for the data given above. Okay, so to complete the table, we are going to count the data and fill tally column for each datum as /, and for the frequency, we just count the total number of tally in a particular row as follows. Okay, so for the first one, height in a centimeter, 21 to 30, the number of tallies are going to be 1, 2, 3, 4, 5, and the frequency is 5. Okay, so for the second class, 31 to 40, number of items are 1, 2, and the frequency is 2. The next class is 41 to 50. Then we count the tallies as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the frequency is 11. The next class is 51 to 60. Then the tallies are 1, 2, 3, 4, 5, 6. and the frequency is 6. The next class is 61 to 70. The tallies are 1, 2, 3, 4, 5, 6, and the frequency is 6. The next class is 71 to 80. The tallies are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the frequency is 10. Our next class is 81 to 90. The tallies are 1, 2, 3, 4, 5, 6, and the frequency is 6. And our final class is 91 to 100, and the tallies are 1, 2, 3, 4, and the frequency is 4. Then this is the table required. For part B, we are supposed to draw a histogram for the heights of the plants. Okay, so for this one, we know that histogram is the rectangular bar graph and it is drawn by frequency against their class mark. Okay, so from our table, we are going to add the class mark column by finding the average of a lower limit and the upper limit for each class interval. So for example, for the first one, we are going to take this 21 plus 30 divide by 2, which solving this we are having 25.5. Okay, so using the same approach, let us fill the rest of the class marks. So here the value is going to be 35.5. And here is 45.5. Here is 55.5. Next is 65.5. The next is 75.5. Next is 85.5. And the last one is 95.5. Okay, so now we are going to draw the histogram. We draw the axis and we are going to mark as class mark and frequency, assign the scales, and we are going to mark the points and we are going to draw the bars. We are going finally to shade the bars. Our final sketch is going to be like this. For part C, find the mean height of the plants. Do not use the assumed mean method to find the mean. Okay, so now let us add another column for the product of the frequency and the class mark, which marked as fx. Okay, so to find the values for the fx, we are going to take the frequencies times the class mark. For example, for the first class, we are going to take 25.5 times 5, of which solving that, the value is going to be 127.5. Okay, so using the same approach, the next value for the next class is going to be 71. The next is 500.5. Next is 333. Next is 393. Next is 755. Next is 513. And the last one is 382. Okay, so let us finalize our table by finding the summation of a frequency, which after summing the values, the answer here is going to be 50. And also, let us find the summation of fx, which after summing the values, the answer here is going to be 3075. Okay, so next, let us now find the mean. We are going to recall the formula to find a mean, which says mean represented by x bar equals to summation of fx over summation of f. Let us now substitute the values from the table. Then we are having x bar equals to 3075 over 50. So for this one, after solving the values, we are having 61.5. Therefore, the mean is going to be 61.5 centimeters. For part D, we are supposed to find the median of the heights of the plants. Okay, so to find this, we are going to add a cumulative frequency column. Okay, so for the first class, our cumulative frequency value is going to be 5. The next one, we are going to take 5 plus 2, which equals to 7. The next one, we are going to take 7 plus 11, which equals to 18. Let us use the same approach to finalize the rest of the values. So next is 24, next is 30, next is 40, next is 46, and the last one is going to be 50. Then we need to identify the middle class by taking sum of the frequencies divided by 2. That is n over 2, which taking this one we are taking 50 over 2, which solving this we are getting 25. Okay, so from the cumulative column, 25 lies within 30 datum. Therefore, the middle class is 61 to 70. The median can be found from the following formula, which says median equals to L plus, in brackets, n over 2 minus FB over Fm times C, whereby L is a lower real limit. Taking the values which we have, the lower limit is going to be 61 plus 0.5, which solving this we are getting 61.5. FB is the sum of the frequencies below the middle class, which equals to 24. And Fm is the frequency of the middle class, which we have is 6. And C is the class size, which equals to 10. Okay, so now let us substitute these values into our formula. Then our equation is going to be median equals to 61.5 plus, in brackets, 25 minus 24 over 6 times 10. Solving this, we are having median equals to 63.167 centimeters. Question number 13. In the figure below, BC is the diameter of the cycle, O is the center of the cycle, and side CD of the cyclic quadrilateral ABCD is produced to E. For part A, with reasons, name the right angles in this figure. Okay, so for this one, the right angles are angle BAC and angle BDC. And the reason being, an angle formed at the circumference is half the angle at the center in the same segment. For part B, show that angle ADE equals to angle ABC. Okay, so from the figure, angle ABC plus angle ACB equals to 90. And angle ADB plus angle ADE equals to 90. This implies that angle ABC plus angle ACB equals to angle ADB plus angle ADE. But angle ACB equals to angle ADB because they both formed with the same segment AB. Then we can say that angle ADE equals to angle ABC, and this has been shown. For part C of the question, if angle ADE equals to 60 and angle CAD equals to 25, for Roman 1 we are supposed to find the value of angle ABD. Okay, so from the figure, angle ABC equals to angle ABD plus angle DBC. Let us call this as equation number 1. But angle ADE equals to angle ABC, which equals to 60 as given above. Also, angle DBC equals to angle CAD, which equals to 25. Since both are angles formed within the segment DC, then our equation number 1 will be 60 equals to angle ABD plus 25. Okay, so now let us collect the constant terms. Then our equation is going to be angle ABD equals to 60 minus 25. Solving this, we are having angle ABD equals to 35. For Roman 2, we are supposed to find the length AB. Okay, so to find this, let us consider the triangle ABC. So let us simply sketch our triangle. Then here the value is A, and here is B, and here is C. Okay, so here is 60, and here is 10 centimeters. Okay, so now let us recall the cosine formula, which says cos theta equals to adjacent side, in our case is side AB, over hypotenuse side, in our case is side BC. From our figure, theta equals to 60 and side BC equals to 10. Then let us substitute these values into our formula. We are having cos 60 equals to AB over 10. So next, let us make AB as a subject. Then our equation is going to be AB equals to 10 times cos 60. Reading from the table, cos 60 equals to 0.5. So let us substitute this into our equation. Then we are having AB equals to 10 times 0.5, of which after solving this, we are having 5 centimeters. Question number 14, part A. What is the trial balance and what is the main purpose? A trial balance is a statement that shows all the accounts' debits and their credit balances. The main purpose is to ensure that companies' bookkeeping systems are mathematically correct. Part B of the question. On January 1st, 2015, Semolina Women Group started a business with a capital in cash of 2 million. On January 2, they purchased goods for cash 1.4 million. So we've been given several transactions there. For Roman 1, we are supposed to prepare the cash account. Okay, so we have to recall that the cash account is the ledger in which all cash transactions are recorded. It has a debit and a credit side. Only cash transactions are recorded and credit sales or purchases are ignored. So we are going to sketch our cash account, which is going to have two sides, the debit side and the credit side. and then the cash account will have columns for date, particular, folio, and amount. Okay, so we start first recording the capital in cash, 2 million. Okay, so next, the cash purchases, 1.4 million. The next transaction is cash sales, 1 million. The next transaction is purchases of good for cash, 600,000. The next is rent payment, 220,000. The next is payment of wages, 220,000. And our last transaction is cash sales, 620,000. Okay, so now let us finalize our cash account by finding the sum here. So after summing the values, the total here is going to be 3,620,000. So we are going to take the same figure on our credit side as well, 3,620,000. So next, we are going to find the balance carried down as a cash in hand at the end of the period. Okay, so after calculating the values, the balance carried down here is going to be 1,180,000. And this is going to be the balance brought down on a following period, 1,180,000. And this is our cash book requested. For Roman 2, we are supposed to prepare the trial balance. Our trial balance will summarize all the account balances as listed in our cash book, such that all the debit entries are going to be credit, and then all the credit entries are going to be debit. Okay, so let us prepare our trial balance, which is going to have 4 columns. The first one is particular, the next is folio, then debit balances and credit balances. So taking from the cash account, the first one is cash account itself with a debit balance of 1,180,000. The next is capital account with 2 million. The next is purchases account with a debit balance of 2 million. The next is sales account with a credit balance of 1,620,000. The next is a rent account with a debit balance of 220,000. The next is wages account with a debit balance of 220,000. Okay, so next let us summarize our trial balance by finding the total on a debit side and on a credit side, of which after summing the values, the total here is going to be 3,620,000. And also on a credit side, after summing the values, the total is going to be 3,620,000. And this is our trial balance requested. Question number 15, part A. Find the inverse and an identity matrix of A with those values. Okay, so this is the matrix problem. So let us first find the inverse of a matrix. To first find the inverse of a matrix, we are going first to find the determinant of a matrix D, which is given by determinant equals to product of a main diagonal minus product of a leading diagonal. Okay, so we are going to take 6 times 5 minus, in brackets, negative 2 times 4. of which after solving the values, we are having 38. Okay, so next we are going to find the adjoint of matrix A by exchanging elements in main diagonal and negating the leading diagonal. Then adjoint of matrix A is going to be matrix 5, 2, -4, 6. Then the inverse of a matrix is going to be a product of a reciprocal of a determinant and adjoint matrix. Then we can write this as A inverse equals to 1 over D times adjoint of a matrix A. So now let us replace the values for the determinant and adjoint A. Then A inverse equals to 1 over 38 times matrix 5, 2, -4, 6. Okay, so next let us apply the scalar multiplication of a matrix. Then we are having A inverse equals to matrix 5 over 38, 2 over 38, -4 over 38, 6 over 38. Okay, so simplifying these elements, we are having 5 over 38, 1 over 19, -2 over 19, 3 over 19. And this is the inverse of matrix required. Okay, so next we are going to find the identity matrix of this one. Then we say identity matrix equals to product of a matrix and its inverse. Since this is the 2 by 2 matrix, then the product will give the matrix as matrix 1, 0, 0, 1. And this is the identity matrix required. Part B of the question, triangle OAB has vertices of those values. If the triangle is enlarged by E equals to matrix 2, 0, 0, 2, then translated by T equals to -3, -5, find the vertices of the triangle. Okay, so for this one, we are going to start by enlargement transformation, of which from relation we say image equals to enlargement matrix times point. So we are going to start with point O with 0, 0. Then image O equals to matrix 2, 0, 0, 2 times matrix 0, 0. Of which, applying the multiplication of a matrix, we are going to get image of O equals to matrix 0, 0. Our next point is point A with 2, 1. Then A image equals to matrix 2, 0, 0, 2 times matrix 2, 1. Okay, so now let us apply multiplication of a matrix. We are having matrix 2 times 2 plus 0 times 1, 0 times 2 plus 2 times 1. After solving the values, we are having matrix 4, 2. Our next point is point B with -1, 3. Then B image equals to matrix 2, 0, 0, 2 times matrix -1, 3. Multiplying this, we are having matrix 2 times -1 plus 0 times 3, 0 times -1 plus 2 times 3. of which after solving the values we are having matrix -2, 6. Okay, so next let us now translate the image points using the translation factor given. Using the translation relation which says image equals to point plus translation factor. Okay, so we are going to start with point 0 image with 0, 0. Then O image equals to matrix 0, 0 plus matrix -3, -5, of which after solving the values we are having matrix -3, -5. Our next point is A image with 4, 2. Then A image equals to matrix 4, 2 plus matrix -3, -5, of which after solving the values we are having matrix 1, -3. And our last point is point B image with -2, 6. Then B image equals to matrix -2, 6 plus matrix -3, -5, which after solving the values we are having matrix -5, 1. Therefore, our final vertices are -3, -5, 1, -3, and -5, 1. For part C, draw on the same XY plane triangle OAB and the images after being, for Roman 1, after being enlarged. Okay, so for this one, we are going to start by drawing axes, and then we are going to label them, making the points and the image points. And then finally, we are going to draw triangles by connecting the points. And then our final sketch of a triangle and the images are going to look like this. Question number 16, part A. A function f is defined on the set of integers as follows. So we've been given several values of function of x there. For Roman 1, we are supposed to draw a pictorial diagram for function of x. Okay, so this is the step function problem. To draw the function, we need to draw the functions given one at a time in the same plane. Okay, so we are going to start by finding points from each line. So we have function of x equals to 1 plus x, with the values of x as 1 less or equal to x less or equal to 2. Okay, so we are going to let function of x equals to y. Then our function is going to be y equals to 1 plus x. Okay, so to get the values of y, we are going to prepare a table of values as follows. So we sketch our table. Then here we have x, and here we have y. So we have the values of x as 1 and 2. So we say when x is 1, y is going to be 2. And then when x equals to 2, y is going to be 3. So next we have the function of x equals to 2x minus 1, with the values of x as 2 less or equal to x less or equal to 4. Then we are going to let function of x equals to y. Then our equation is going to be y equals to 2x minus 1. Okay, so we are going also to prepare a table of values. Then here is x and here is y. Then here we have 2 and here is 4. When x equals to 2, y is going to be 3. And when x equals to 4, y is going to be 7. Okay, so we also have function of x equals to 3x minus 10 with the values of x as 4 less or equal to x less or equal to 6. Again, we are going to let function of x equals to y. Then we are having y equals to 3x minus 10. Then preparing the table of values. So here we have x and here we have y. So the values here are 4 and 6 for x. Then we say when x equals to 4, y is going to be 2. And then when x equals to 6, y is going to be 8. Okay, so now we have the points for each function. Then next we are going to draw the graph. We have to note that we have to draw the shaded cycle showing that the points are included due to the use of a greater or equal sign. So we are going to start by drawing the axis, and then we are going to label them, and then we are going to make the points. Then we are going to connect the points using straight lines. And our final sketch will look like this. For Roman 2, we are supposed to find the domain and range of function of x. We know that domain are values of x and range are values of y in a function. So from this graph, domain is such that 1 is less or equal to x, and x is less or equal to 6. And also, the range is such that 2 is less or equal to y, and y is less or equal to 8. And those are our answers. Part B of the question, given that function of x is given by those values, we are supposed to find inverse function of 4. Okay, so before we find the inverse function of 4, let us first find the inverse function of x. So we are going to let y equals to inverse function of x. Then our equation is going to be y equals to 5x plus 7 over x plus 2. Okay, so next we are going to interchange the variables for x and y. Then our equation is going to be x equals to 5y plus 7 over y plus 2. Okay, so now let us cross multiply this equation. Then we are having x in brackets y plus 2 equals to 5y plus 7. Okay, so next we are going to expand our left hand side. Then our equation is going to be xy plus 2x equals to 5y plus 7. Okay, so next let us combine the terms which contains y. Then our equation is going to be xy minus 5y equals to 7 minus 2x. Okay, so let us now fact out y on our left hand side. Then our equation is going to be y in brackets x minus 5 equals to 7 minus 2x. Next, we are going to divide by x minus 5 both sides. Then our equation is going to be y equals to 7 minus 2x over x minus 5. Okay, so now we are going to let y equals to inverse function of x. Then inverse function of x equals to 7 minus 2x over x minus 5. Okay, so now in order to find the inverse function of 4, we are going to substitute x with 4. Then our equation is going to be inverse function of 4 equals to 7 minus 2 times 4 over 4 minus 5, of which after solving the values, we are going to have 1. And this is going to be our answer. Part C of the question, in a yard there are 500 vehicles, of which 160 are cars, 130 are vans, and the remaining are lorries. If every vehicle has an equal chance to leave, we are supposed to find the probability of, for Roman 1, a van leaving first. Okay, so this is the probability problem. We have to recall that probability of an event equals to number of events over number of sample space. So probability for van leaving first equals to number of van vehicles over total number of vehicles. So let us substitute the values given from the question. Then probability of van leaving first equals to 130 over 500, of which after solving the values we are having 13 over 50, and this is going to be our answer. For Roman 2, we are supposed to find the probability of a lorry leaving first. Okay, so still using the same formula, probability for a lorry leaving first equals to number of lorry vehicles over total number of vehicles. Now to find the total number of lorries, we are going to take total number of vehicles minus number of cars minus number of vans. Okay, so given the values from our question, number of lorries is going to be 500 minus 130 minus 160, of which after solving the values we are having 210 lorries. Now its probability is going to be 210 over 500, of which after solving the values we are having 21 over 50, and this is the probability required. For Roman 3, we are supposed to calculate the probability that a car leaving second if either a lorry or a van had left first. Okay, so for this one, when a car is leaving second, then the total number of sample space is going to be 500 minus 1, which equals to 499. Then the probability of a car leaving second is going to be 160 over 499. And we have seen that a probability of a lorry leaving first is going to be 210 over 500. And also a probability of a van leaving first equals to 130 over 500. Okay, so to find a probability that a car leaving second if either a lorry or a van had left first, then we are going to take probability of a lorry leaving first while car leaving second times probability of a car leaving second plus probability of a van leaving first while car leaving second times probability of a car leaving second. Okay, so now let us substitute the values into our formula. Then our equation is going to be 210 over 500 times 160 over 499 plus 130 over 500 times 160 over 499, of which after solving the values we are going to have 544 over 2495, and this is going to be our answer.